Stack. The stack is a designed memory area used for storing local variables and parameters. Its size dynamically increases and decreases as methods or functions are entered or exited. Let's examine the following method where I'll show you how values are stored on the stack and how they pop out from the stack. Okay, let's consider the static method, which returns integer. We will be passing for this function integer. We will call it x. At the end, we will return the value. For example, we pass 5, we get 15. We pass 100, we get 550. So all the numbers summed up, starting from 1 up to the number we put as parameter x. So we return, which is if x will be 1, we return 1, and if that is not 1, then we x plus sum up to, that will be a recursion, x minus 1. That's how we do it. So we will try and check that it works just fine. So we do var ret, which is return, and then we sum up to, and we will passing 15. Let's do 5 and 100. We console the right line, both ret 1 and ret 2. Console right line, and we start again. .NET run. All right, so it's 15 and 550. But what's happened here? I'll explain to you. And we can see the stack is being run, how integers are allocated on that stack. So we go start debugging. And here we see on the left 2 functions. And that is with the main function, which is, we know that main function run under the hood, so we don't have to write it. So I didn't write it, but we still can see that on the call stack, which is the main function, it starts first. And then our function starts with number 5. So what happened? We put 5 here and we check 5 equals to 1. No, it's not equal to 1, then 5 plus. And we call the function again. That function is stored on the stack. We go again. Okay, now here's the 5, and then we run it again because we put the 5 minus 1 will be 4, and we're calling with 4 again. 4 equals to 1. No, it's not equal to 1. 4 plus sum up to 4 minus 1. That will be 3. Okay, let's iterate one more time. That's the number 3, and we already have 1, 2, 3 functions are waiting on execution. They are on the stack. And then we go again. So we pass 3 here. 3 equals to 1. No. Then we go here. 3 plus sum up to 3 minus 1, 2. Okay, go again. So we pass 2 here. 2 equals to 1. No. 2 plus sum up 2 minus 1 will be 1. Here we go again. We're passing here 1. 1 equals to 1. That's true. We return 1 from this function. See how it goes. We return 1. And then we start throwing all the functions we have from the stack. Returned 1. And then we check 3, because as you know, we stored our variable on the stack were 3. Again, 4, and we're summing up. We're summing up them. 5, we already have 10, and then 15. That's the final return from the function, which is the 15. After execution, all of the functions pop out from the stack. And then we go to another call, which is sum up to 100. We're not going to iterate for all of 100, but it goes the same way. So we pass 100, and then after we decremented 1 from 100, we start passing 99, and then it goes 98, then it goes 97. We do it many, many times, and it's all stored on the stack. And after we reach the point of 1, we start just popping from the stack all of that functions because they return something. And we just sum everything up. That's why we have for 5, 15, and for 100, 515. So that's how stack works. We will be talking about stacks in more greater details in the future.